AP Calculus, let's get rocking and rolling. It's Thursday, then it will be Friday, then the weekend, then Monday, and then the day of your AP. I hope you're preparing, okay? I hope you're not slacking off. Like I've said before, if you got crazy things going on at home, I understand the slacking off, okay? But if, not, you might feel overwhelmed. I get it. You got a lot of advanced placement exams coming up, but you got to do the best that you can, okay? You got to run through that demo. You got to know about uploading your answers. This is going to be the first test. Really, the test that you're probably going to be uploading pictures for are really going to be, AP Calculus, AP Chemistry, and AP Statistics. Those are the main ones where it's hard to upload answers. Maybe Physics as well. But this is going to be the first one like that, okay? Monday, I forget what AP exam there is, but it's not an AP exam where you really have to worry about uploading pictures. So look, you guys are going to be the guinea pigs for this system here, which means you have to practice this. I don't want you to, have a bad test day and then none of your answers upload. Then you got to worry about retaking the exam. We want to try to avoid that. And the way you're going to avoid that is to be prepared. Look at the demo. Watch that YouTube video I posted, okay? Not of me, but of another teacher. She does a much better job. She's got a much better setup of the demo. Probably the best way to do it is to, you can only open it up on one device, okay? You can't have it open on your laptop and your phone at the same time. It's not the way it works. So the best way is probably to have it open on your laptop and then to take pictures with your phone and either email them to yourselves or use Google Drive. She explains it on the video. It seems pretty simple. You could also take it on your phone or a tablet. It's probably the easiest way because then you could just take a picture and then it's easy to upload. I did it myself, practicing. But the problem is then you got to look at questions on a really small iPhone screen. You got to zoom in. Look at all this writing, stuff like this. You better make sure you could read stuff like that. Even if you're looking at a laptop screen, you're not going to be able to underline it and things like that. So it's not going to be so easy. Okay. So do the best you can, but I want you to be prepared. Make sure you have those, sheets written out, blank pieces of white paper. You put your initials on top. You put your AP ID on top. And then you also, number the pages. Have a couple pages set up for each question, okay? Maybe 2 to 3 pages set up for each question. You only have 2 questions, okay? But you don't want the uploading to be an issue. Make sure if you want to upload multiple pictures that you don't hit submit in between. If you hit submit, that's really submitting all your stuff, okay? So if you do hit submit, it's going to warn you, it's going to go on to the next question. Do you have all your work submitted? You want to attach multiple pages before you submit. Practice this stuff. Don't leave it to the last minute because on the day of the exam, I want you thinking about calculus and what we're working on right now, free response practice. I don't know, 5.4? I think it's 5.4. These are actually questions that are from AP Classroom that were uploaded that were released. So a lot of AP teachers think it's kind of like a wink as far as the types of questions you're going to see on the exam. But I could tell just by looking through them that most of them are questions that were created by AP teachers, which is great, okay? It's just that some of the questions they ask are a little bit different from some things you'd normally see on an AP, but it's still great practice, okay? Over the weekend, I'm going to have a big document, 12 part 2 questions. Please try them, okay? Put in your work. We'll post those tomorrow. You also have some homework for tomorrow. I know it's a lot of work, okay? But this is going to be a big weekend of work for you. That Monday we'll have another lesson. You have a little bit of homework on Monday. Maybe Tuesday I'll make a video. I probably won't though. I'll probably just, upload a question or 2 for you to practice. But that's last minute practice, really. That's the day of the AP. So you should have most of your practice in before. And it's not too late. If you've been slacking off, it really isn't, okay? If you start working right now and this weekend, you'd be surprised. You might still be able to pull a decent grade out. I hope you're not just planning on cramming everything. The secret to AP review is to do a little bit every day to keep these things fresh in your mind, okay? Enough about that. Let's jump into some work right here. So this problem, very interesting looking function right here. They tell us the graph of f. They tell us the continuous function f is defined from -4 to 4. So they're actually describing the graph that they're given, which doesn't always happen. A lot of times they give a graph of something, then describe a different function. The graph of f shown above consists of 2 line segments. You can see it right there. And portions of 3 parabolas, okay? The graph has horizontal tangents at x equals -1/2. So right there, a little horizontal tangent line. X equals +1/2 right there. And x equals 5/2. You can ascertain with the naked eye that there's a slope of 0 in those 3 spots, but it's kind of hard to tell what the x values are. So they're telling you that it is known that f of x between 1 and 4 is actually this parabola right here. Okay, so they give you the algebraic representation. Then they tell you the areas of regions A and region B bounded by the graph are 3 and 5 respectively. So I know this area right here is 3 and this area right here is 5. We've seen some stuff like that before. And then they say let g be the function given by this function right here. A lot of these questions they posted to AP Classroom deals with this type of function. You know what type of function is. You know it's an accumulation function. We dealt with this in review. Let's deal with this now, okay? We're going to do a few problems like this. We're going to do another one tomorrow. You'll see them over the weekend. They're really pushing this, so this might be one of the problems that you see. Would not surprise me if one of your problems was a graph of, a derivative or an accumulation function problem. They're really the same thing, because remember, to take the derivative and accumulation function, drop that variable upper bound in for the independent variable, so f of t becomes f of x. Then don't forget the integral sign go away, and the dt goes away, okay? So this right here is something you want to write down right away. You also want to say that g double prime of x equals f prime of x. This will help you out later on in the problem. They're going to ask you questions about g down here, but you got to justify in terms of f. By the way, f right here is g prime. So it's really the same thing as a graph of a derivative problem that we've spoken a lot about. So when you justify, you'd have to justify in terms of f. You always got to justify in terms of the information you're given. If you accidentally justify in terms of g, at least there's a little bit of relationship between g and f here. But really the idea is to justify in terms of f. Your AP exam, 2 questions. I really feel like one will be applied and one will be abstract. This will be an abstract question. I really feel like one of your questions is going to be a differential equation question. We'll talk about that tomorrow. We'll do another one on Monday as well. You'll see it over the weekend. You'll see a bunch of those. The problem is differential equations, it's could be an applied problem, kind of like the one that you just had assigned with the potato in the oven. I know it's tough. We did one with landfill. We did one with a baby bird. Make sure you take a look at those, okay? I don't know. Maybe both your problems will be abstract. One won't be applied. I don't know. Maybe the first problem would just be like a bunch of short answer, like a bunch of multiple choice stuff. We'll see. Anyway, if you want g of 0, you don't need this information over here. Take out the 0, take out the x, replace it with a 0. Take out this x, replace it with a 0. So g of 0 is really going to be the integral from -4 to 0 of f of t with respect to t, which is the graph that we have right here. If you integrate -4 to 0, you're integrating forward, okay? And there's 2 regions here, okay? So you can see first you should integrate from -4 to -1. Then you should integrate from -1 to 0. -4 to -1, we want the area of this big triangle. You can see the base is 1, 2, 3. The height is actually 3. Be careful. The scale's a little bit different on each axis here, but you can see the height is 3 right there. The base is 3. So 1/2, 3 times 3 is really 9/2. That's what my area is here. You're integrating forward the regions above, so that's a positive 9/2. Then I'll put plus, even though now this part, we're integrating forward the regions below, right? So we're going to get a negative representation for an integral, negative of whatever the area is they tell you. So I'll just put plus -3, and whoop, there it is. Don't simplify it. You can write it out any way you want. If you want to do g of 4, obviously a lot more complicated here. G of 4 is the integral from -4 to 4 of f of t with respect to t. And if you integrate from -4 to 4, at least you're still integrating forward. But think about it. Integrating from -4 to 4, 4 regions here, right? The integral from -4 to -1, the integral from -1 to 0, the integral from 0 to 1, then the integral from 1 to 4, okay? The integral from -4 to -1 we already know is positive 9/2. Whoop, there it is. Plus, the integral from -1 to 0 we already know is equal to -3. Plus, the integral from 0 to 1, integrating forward the regions above, it's going to be positive, whatever this area is, it's going to be 5. And then the problem here is that now they don't tell you this area. They tell you the equation from 1 to 4, right? They tell you the rule for the function is -x squared plus 5x minus 4. So that part, we still need to do the integral from 1 to 4 of f of t with respect to t. And I'll do that over here, okay? If you do the integral from 1 to 4 of f of t with respect to t, just remember f of t here is really -x squared plus 5x minus 4, all with respect to t. So here they're kind of throwing in like a conventional integral over here. I've never really seen it like this before, but they could put things like this together for the AP. There's always going to be stuff that shows up that you don't exactly, that you haven't seen before. It doesn't mean you don't know how to do it. So this is -x cubed over 3. Pull the negative to the side, add 1 to the exponent, divide by that number. Plus, pull the 5 to the side, integrate x to the first, x squared over 2. Minus the integral of 4 with respect to t is going to be 4t. And we'll evaluate all that from 1 to 4. Remember, you don't have to simplify, okay? So when you plug in the 4, the negation of 4 cubed, okay, plus, I'll say this is 5/2 x squared, so 5/2 times 4 squared, minus 4 times 4. Okay, that's plugging in of the upper bound right there. Now we subtract the plugging in of the lower bound, so the negation of 1 cubed over 3, plus 5/2 this time times 1 squared, minus 4 times 1. And this thing right here, you know, if you can see it, okay, it's really filthy, but you just get to take this entire thing and you're going to put it right in here, okay? So look, you know, it's kind of silly. We're not going to simplify this. Don't waste time simplifying this. Remember, we still got that 9/2 plus the -3, so I'll say minus 3 plus the 5. And then we're going to add this entire expression, okay? And just be careful. You want a set of brackets around it. Will that matter, actually? Do we want to subtract those first before we add? If I put a plus sign, I don't think it's going to make a difference if you just put plus and then put this thing down here. But just in case, we're going to do this over here. It's tough when you're dealing with expressions that aren't simplified to actually play around with things. That's why we usually do try to simplify, but I would not waste your time with that on this AP exam, okay? You will lose a point if you have the right answer, but you simplify incorrectly. Every AP teacher I talk to, every AP listserv I go on, they all say, do not simplify. And I say do not simplify, and my word is law. Okay, so it looks like this is the answer right here. As ridiculous as that might seem, stick it to the squirrels. Okay, anyway, part B, find the absolute minimum value of G on the closed interval -4 to 4. Even if they said find the minimum value of G on the closed interval -4 to 4, it's implied it's absolute because the endpoints are included. And look, I mean, G is the original function. And you want to find where G has a minimum. You know, during the AP, you should be thinking in your head, well, surely there must be some sort of test, okay? And of course there is. The first derivative test to find a min, so that's the G prime line. But remember, the G prime line is the same thing as the F line. So we're really drawing the F line, and you know F goes from -4 to 4, so tis it bounded? It is from -4 to 4, which is what they asked us to check anyway. I don't know, maybe they'll only ask you -4 to 1 in certain problems and shorten the interval. They don't do that often, but they could. And now look, I gotta draw the, that's why I draw the line. What line? The F line, okay? You telling me I want to draw the line for the graph that I'm given. That's when I check above and below, and you can see we're above from -4 to -1. Okay, so we're going to have a positive F right there, a positive G prime. Then you can see that we're below from -1 to 0. And then you can see that we are now above the rest of the way. But just be careful. At 1, you're technically not above. You're equal to 0. So we'll say above from 0 to 1. And then above from 1 to 4. Okay, and you know at -1, 0, and 1, those are places where G prime is equal to 0. Okay, so they're going to have a horizontal tangent line right there, G. And you also got to check the endpoints. But right here at -1, we can see G prime, the slope of G, changed from positive to negative. G changed from increasing to decreasing. That's a max. I want a min, so we're not going to worry about him. We do care about 0, right? Because we got a min right there. We don't care about 1. There's no extrema, okay? The graph actually goes from increasing to increasing. Do I care about -4? Function starts, increases immediately. Heck yar, that's a min. Do I care about 4? Function increases, then stops? No, that's a max, okay? So I got my mins. I don't know how to spell mins. Who knows how to spell? Not me. Try to have one of these on hand if you're using pen during the AP exam. Pencil might be good, but make sure you're taking pictures. Don't have shadows on these pictures. Make sure it's clear. Put the phone above, not at an angle like some of you guys do when you submit your work. And if you do use pencil, make sure it's dark enough. Okay, so we got mins here, and we got mins at what? -4, comma G of -4, right? Because we want to plug back into the original. That's an endpoint. We don't need to justify it. But we have another one at 0, comma G of 0. And remember, this is because we got to justify it right here. We know it's because G prime equals 0 and changes from negative to positive, but you got to justify in terms of F. So it's because F equals 0 and changes from negative to positive. Be careful with stuff like that, okay? And make sure you practice on your AP. You're not going to have time to finish everything, okay? So make sure you skip over the parts you don't know how to do and then go back. Hopefully you don't, skip everything and then go back right to the beginning again. That would be troublesome, but there should be some stuff you can get points on. Hey, -4, comma, we got to get Y values here, right, to see which one's the absolute min. G of -4, it's the joke of the year. The integral from -4 to -4 of f of t with respect to t, that's 0. Mr. Pushy's IQ, okay? If the bounds are tied, there ain't no region to get the area of. And 0, comma G of 0, how cool is that we did it before, right? So what was it, 9/2 minus 3? We didn't simplify this before, but now you need to know what this is equal to. Well, not really, actually. You just need to know whether it's greater than 0 or less than 0. 9/2 is really 4.5, right? And 4.5 minus 3 is 1.5. That means that 0 is less than this 1.5. So we know this is the absolute min. So absolute min at x equals -4 because, remember, absolute extrema, you better be showing me that you're comparing y values, showing that either y values are lower than other y values or bigger than other y values. In this case, lower. G of -4 is less than G of 0. And then don't forget to answer the question. They didn't want to just know where the absolute min occurs. They wanted to know the absolute minimum value. So the min value, remember, a function always represents y values, okay? So that's G of -4, which we know is actually equal to 0. Try to box things in. Sometimes it's tough. Like here, it's easy. You knew what your final answers were. But here, there's a lot of stuff going on. Like technically, this is the final answer, but you need that analysis. And remember, these lines right here, they don't mean anything. Okay, it's why you need to justify stuff. Okay, but it's a great way to organize your work. Now find all intervals on which the graph of G is honk down. All right, concave down. Well, surely there must be some sort of test, and G is the OG function, and there is. It's the second derivative test. So I want to draw the G double prime line, which, remember, is the same thing as the f prime line, okay? So now it's going to go from -4 to 4, because f goes from -4 to 4, so his derivative will go from -4 to 4. Sometimes derivatives don't exist in endpoints. They never ask about that on the AP. And look, now, here's f prime. I got the graph of f. You tell me I want to draw the line for the derivative of the graph that I'm given. Is that what you tell me? Huh? That's when you check increasing and decreasing slope. When is the slope positive? When is the slope negative? When is the slope 0? Okay. Here, where's the slope undefined? Here, this thing increases from -4 to -2, then the slope's undefined. You don't really need to put the DNE part there, okay? For certain questions you might. Then you can see it decreases all the way from -2 to -1/2, okay? We're looking for concavity here. This thing is not going to change. The slope doesn't change sign from, here all the way to here, okay? It decreases, the slope's negative, then it decreases again, the slope's negative again. Even if there's a place where the slope doesn't exist, it doesn't make a difference, okay? So here, because you can still decrease or increase when your slope doesn't exist, okay? If you got like a vertical tangent line, your slope doesn't exist, you can still decrease over there, okay? So you don't need to worry about it. It decreases from -2 to -1/2. All right, then we could say it's increasing from -1/2 to +1/2. Then we could say it decreases from +1/2 to 1. It's a really annoying graph here because now it increases from 1 to 5/2. They told you these values. It increases and then decreases from 5/2 to 4, right? Okay, so I got my line right there. Hopefully it's all right. Complicated line. When is G concave down? Well, we should now know when it's concave down. So G is conc down. And that's going to be on the open interval -2 to -1/2. And also from 1/2 to 1. And then also it looks like 5/2 to 4. Don't forget to justify because, and look, if you say that G double prime is negative, you're wrong, okay? Because they're going to want to know why G double prime is negative. Well, remember, G double prime being negative, same thing as F prime being negative, right? And then you could be like, okay, because F prime is negative. But that's not justifying in terms of F, okay? How do you know that F prime is negative? Well, you know that because the slope of F was negative, because F is decreasing, You could also say F has a negative slope. That will also work, okay? Not the worst problem in the world. It's kind of cute. This is weird. I've never seen something exactly like this on an AP exam, but it could show up. So whoever created this problem, I think it's actually a pretty decent one. Moving on to this guy over here, the top will be cut off. But on your answers, the top is there, okay? So don't start yelling and screaming at me. They say consider the curve given by the equation, this guy right here. So it's defined, implicitly. It's a function of x and y. Find for all points on the curve, they tell you the derivative is always in between 2/3 and 2, which actually doesn't come into play until the last part of the problem, which is a little tricksy and weird. They want you to show that this derivative right here is equal to this guy, and this is another type of problem that there's a couple of these that have showed up on AP Classroom. We did a few of these. If you look at differential equations, I think it's day 2. So if we go back to, I think it's 3.6, day 2 for differential equations, we did some, because the implicit differentiation can really factor into differential equation types of problems, okay? So we did one of those where I think differential equations really wasn't involved, and it was similar to this. And you also had one for homework. You'll have another one for homework over the weekend. I'll give you another one as well. So really we kind of focus on the things that I'm trying to predict are on the AP exam, but we'll also give you a nice mix as well, because who knows what's actually going to be on there. Just because they release these in AP Classroom doesn't mean the problems are going to be like this, okay? But let's, focus on these just in case. Take the derivative. There's a couple different things you could do. You could distribute the 2x if you want, or you could just take the derivative right away, like pull the 2 to the side. Take the derivative of x with respect to x. Remember, we want to show that dy over dx is equal to this right here. The derivative of x with respect to x is 1, but the derivative of y with respect to x is dy over dx. Don't forget, implicit differentiation, whenever you see x's and y's frolicking about together, it's an implicit differentiation situation. Whenever you want to take the derivative with respect to one variable and there are other variables present, that's the real definition of an implicit differentiation situation. You could have easily made this 2x minus 2y. Right, distributed, and then, you actually get, over here when we distribute, we get 2 minus 2 times dy over dx. Just kind of jumping ahead over here. That's what would happen here. The derivative of 2x with respect to x is 2, minus the derivative of 2y with respect to x is 2. Put a dy over dx next to it. The derivative of 3 plus cosine y, the derivative of 3 is 0. Derivative of cosine y, be careful. In a world of derivatives, cosine is the bad guy. His derivative is negative sine y. But then you have to indicate respect to x by putting a dy over dx next to it, because you took the derivative of something that had a y in it with respect to x. Or you could just use chain rule, right? The derivative of cosine y is negative sine y. Always rewrite that argument. Function means nothing without its argument. And then multiply by the derivative of the argument. The derivative of y with respect to x is dy over dx. This becomes negative sine y, dy over dx. Usually a good rule of thumb is that we move the dy over dx's to the left-hand side. If you do that here, see how this is a negative sine y, and right here it's a negative sine y? That's going to become a positive sine y. We'll talk about it in a minute, but if you actually move the dy over dx's to the left-hand side, so leave the 2 to the right-hand side, pardon me, leave the 2 on the left, add 2 dy over dx to both sides, so 2 dy over dx, he's going to become positive, right? Then he meets up with that negative sine y dy over dx. And now you can factor the dy over dx's out. I feel siny. And then when you divide by zibubel, you get 2 over the quantity 2 minus sine y is equal to dy over dx. Okay, so we've shown what they want us to show. If you move the dy over dx's to the left-hand side, you'd bring this guy over, right? So you'd become positive sine y dy over dx. He would already be here, minus 2 dy over dx. And then we move this 2 to the right-hand side. We make him negative 2. So if you do it this way, right now, you might do this, obviously. This shouldn't be too difficult for you. But then when you look at your answer, you get this. And that's not exactly what my answer looks like. So essentially, I haven't really shown that. If I were you, I'd just go back and put the dy over dx on the opposite side. It's probably easier than doing this, but you could do this if you want to. Factor a negative out of the bottom. Okay, and then the negatives cancel out, and you're actually left with 2 over negative sine y plus 2, really 2 minus sine y, okay? Which is what we want, isn't it? 2 minus sine y. So what do I have wrong? Oh, yeah. Okay, sorry. I was looking at this. Anyway, so you could do it that way. My suggestion is if you don't get what they want, put the dy over dx on the opposite side and do the problem again. But if you're, literate with algebra, you could do stuff like this as well. Now they tell you for y from negative pi over 2 to pi over 2, which is going to be important. There is a point P on the curve through which the line tangent to the curve has slope 1. Find the coordinates of point P. This is popular with these types of problems, which don't show up all the time, but it could on your AP exam. They'll tell you what the slope of the tangent line is. Every slope of the tangent line, that's the derivative, okay? So they're really telling you what the derivative is equal to. A lot of times, they'll tell you the derivative is equal to 0, which means you want to take the derivative, set it equal to 0, which means if it's a fraction, you just set the numerator equal to 0. Sometimes they want to know, that's where there's a horizontal tangent line, right? The derivative be equal to 0. Sometimes there's a vertical tangent line that shows up on your homework. That's when the derivative's non-existent, so that means his denominator is going to be equal to 0. We saw that already, at least the horizontal tangent line on the ones that we did in 3.6 day 2. But you can see that for homework tonight. Do the best you can. Here they're actually telling you the slope is 1. The most popular slopes are d, n, e, and 0. But they can tell you the slope is 1. They can tell you the slope is 6. Who knows? But if the slope is 1, that means that dy over dx is equal to 1. Okay, so I'm going to say 1 is equal to 2 over 2 minus sine y. And they want to know the coordinates of the point P. So that means I want x and y. And the cool thing is I could solve for y right here, right? Little cross multiplication across the nation. 2 minus sine y is equal to 2. I'll add sine y to both sides, subtract 2 from both sides. So 0 is equal to sine y. I feel siny, okay? So sine y is equal to 0 over here. People are like, how do I solve? Well, technically what you do is you take the sine inverse of both sides, but you don't need to really write. Okay, and you really end up with y is equal to, the sine inverse of 0. This is the angle whose sine is 0. Think about it. You just want to know where the sine function is equal to 0. And they actually tell you an interval, right? This is y. So they tell you where y is in between negative pi over 2 and pi over 2, which is important because if you graph sine, you're used to graphing sine x. If you graph sine y, just make this the y-axis, and this is the sine of y-axis right here. And be careful, sine, we know what it looks like, right? The problem is I don't want to look at this whole graph. I only want to go from negative pi over 2 to positive pi over 2. That's from here to here. And between these two spots, there's only one place where the sine is equal to 0, and that's right here when y is equal to 0. That's why y has to be equal to 0 there. It's a little weird. Just think about it. If they said 0 equals sine x, and they put an x right here, you'd be able to solve it rather easily. They're kind of messing with you because the independent variable here is y. Try not to worry so much about that. By the way, knowing y is equal to 0 is not good enough. Now you need to know what x is equal to. And for that, we're going to plug back into the original. Usually we plug x back into the original to get y. You can also plug y back into the original to get x. Okay, so 2 times the quantity, it was x minus y, right? So now it's x minus 0 equal to 3 plus the cosine of y. So 3 plus the cosine of 0. All right, we end up, this is really 2x equal to, the cosine of 0 is equal to 1, right? Equal to 4. Thus, we know x is equal to 2. So it's really the point 2 comma 0. But if you leave this, you should be good to go. So a little weird. Not something you see a whole heck of a lot, but you can do it, okay? There's going to be stuff that shows up in an AP exam that you don't know how to do, that you've never done before, but you can still do it, okay? You can figure it out. There's also going to be some stuff that shows up that you never did before that you're probably still not going to know how to do. And that's all right. It's all about maximizing those points. Now we want to determine the concavity of the curve at the same, little domain for the points of y right there. You could also call it a range. Give a reason for your answer. Remember, concavity, that's not about the first derivative. That's about the second derivative. So we need d squared y over dx squared. Excuse me. If this right, if this right here is your first derivative, we got to take the derivative of both sides to get your second derivative. Quotient rule makes me drool. The derivative of dy over dx with respect to x is going to be d squared y over dx squared. No problems there. And now we got to use the quotient rule. Back in! All right, we know 2 minus sine y. That's the second function. Like I said before, normally you can't scream those things out during the AP exam because you're in a room with other kids. But now you're in your own private room, so you go on with your bad self and drool. And back in, you telling me all it's good. All that's where I draw the line. All that stuff. Have fun during the AP exam. Make sure you're prepared. You know how to submit those solutions. If you're not prepared, I didn't want to talk to you. Okay, so the second times the derivative of the first. The derivative of the first is 0, so this is going to become pretty nice here. Minus the first, which is 2, times the derivative of the second. The derivative of 2 minus sine y is going to be 0 minus, the derivative of sine y is cosine y, dy over dx. Then it's all over second squared, so all over 2 minus sine y, quantity squared. So this gets a little bit more filthy over here, just so you know. And that dy over dx, okay, that's actually a function that we happen to know, okay? So as far as dy over dx is concerned, let's simplify this a little bit. Okay, let's wipe out the 2 minus sine y over here. Okay, so now we're just going to end up with, up top, we have our a negative times a negative will be a positive. 2 cosine y dy over dx. 2 cosine y dy over dx. And now we're over 2 minus sine y quantity squared. Okay, so that's what d squared y over dx squared is equal to. And think about it. You want to know basically the concavity, okay, between negative pi over 2 and pi over 2. Okay, so you want to know if this thing is positive or if this thing is negative. The good thing is that this down here, 2 minus sine y quantity squared, this is always positive. Okay, because when you actually square something, you get a positive result back. So really, we're just interested in the 2 cosine y times dy over dx. When is it positive? When is it negative? By the way, this thing becomes 2 cosine y, okay, times dy over dx, we know is 2 over 2 minus sine y. So things are getting a little bit more frumpy here. Okay, so it looks like we end up with what? 4 cosine y over 2 minus sine y. And we need to figure out where this thing is positive or negative. I just have something going on. I need to pause this video for a moment. Back in a minute.